Today for Academic Super Bowl, we are going to be talking about finding the area of triangles using matrices. You might remember area of a triangle is half base times height. What we're going to be doing here, we're going to be doing plus or minus 1/2 times the determinant of this matrix. This matrix is going to have AB1, CD1, EF1 if we have coordinates A, B, C, D, and EF on our triangle. Plus or minus 1/2 is going to depend on whether we get a positive answer or a negative answer. We know that we need to have a positive area for our triangle. So we're going to try to find the area of a triangle that has these three vertices. So we're going to start off by plus or minus 1/2 times, we're going to do the determinant. So we're going to start with the coordinates of A are -5, 3, and we'll put a 1 next to that. Coordinates of B are 6, -2, we'll put a 1 next to that. And coordinates of C are -3, 4, and we'll put a 1 next to that. At this point then, if you want to, you can put plus or minus 1/2 out in front just so you don't forget about it. So we're going to do -5 times kind of that bottom right corner, the stuff that's not in the same row and column as the -5, so that'd be these over here. And then we can do minus, we're going to take that top middle number, which is the 3, and then stuff that's not in that row and column would be 6, 1, -3, 1, and then plus the top right corner is a 1, and then stuff that's not in that row and column would be this bottom left corner. So it'd be 6, -2, -3, 4. And this would be good for splitting up into sections. If each person just picks, I'm going to do the first part, I'm going to do the second part, I'm going to do the third part. So if we do this for this first determinant, so we're going to do -2 times 1, which is -2, and then minus 4 times 1, which is 4, and then we'll do -3 times, we're going to have 6 times 1, which is 6, minus 1 times -3, which is -3, and then plus 1 times 6 times 4 is 24, minus this, don't lose that sign, that was -3 times -2, which is negative times negative, that would be a positive 6. And like I said, if you split it up, each person's only doing one part of this, then it's a little bit more manageable. Anytime on subtracting, you can add the opposite. So -4 plus -2 would be -6. And then 6 plus 3 is 9. And then plus 1 times 24 minus 6 is 18. And then if we just multiply those, -5 times -6 would be a positive 30, minus 27 plus 18. Depending on the numbers, you can either just work left to right, or you can get all your positives and negatives together. Normally I'd get positives and negatives together, so I'll just mention that. These would be 48 minus 27. Or you can just work across on this problem. Doesn't work out too bad. So that would be 21. So the number in the middle was positive, and so we know our area is going to be positive, so we know in this case actually it's just going to be a positive half instead of that negative 1/2. And then half of 21 would be 10.5 or 10.5. So 10.5 square units, whatever those are, that would be our area of this triangle. So it's a little tedious, it's not difficult, but there is a lot of computation, so just be careful as you work through finding the area of a triangle. We're going to go through another problem. This is on the worksheet that you have in your packet. It's 2F. It's called matrices using determinants to find area of a triangle. So this is, we're doing bingo here, I guess. So this is G. Okay, so for G, just to start out with, remember you put the coordinates and then put a 1 after it. And then we're going to just do this a different way. We were doing some research. We found videos on a shortcut method for finding a determinant of a 3x3 matrix. So what we're going to do, we're going to take these first two columns and we're just going to rewrite them over to the side here. I'm not sure exactly why this works, but it does. So what we're going to do then is we're going to look for diagonals, starting with diagonals going towards the right, starting in the with the top left corner going over towards the right. And what we're going to do, we're just going to multiply these together. So this is 2 times 0 times 1. Well, that's got a 0 in it, so that's going to be 0. And then our next diagonal, we've got negative 5 times 1 times 3. That'd be negative 15. And then we've got 1 times negative 5 times 4, which is negative 20. And then what we're going to do, we're just going to add those together. So you can add the opposites here if you want. That's going to be negative 35. I copied and pasted this just as an idea that we could not have such a mess, but I think I'm just going to deal with it as it is, because if we were really working this out, we probably wouldn't have time for rewriting it a second time. So what we're going to do for the other part is we're going to look at diagonals going the other direction. So diagonals going the other direction, the first one would be 3 times 0 times 1. That's the first diagonal that we have with 3 numbers. That has a 0 in it, so that's going to be 0. And then next we've got 4 times 1 times 2, which is 8. And then we've got 1 times negative 5 times negative 5, which would be a positive 25. So if we add those together, that would be 33. And then at that point, what we do is we subtract these. We take the first one minus the second one. So negative 35 minus 33 is going to be negative 68. And then in the front of this, if you remember, we had plus or minus 1/2. And we just need to make sure we get a positive answer for our area. So half of 68 would be 34. And then basically we're just going to ignore the sign. I mean, essentially we would be using the negative 1/2 times negative 68. But basically at that point we can just drop all the signs. If it's negative on the inside, we'll just not worry about that. and this gives us our answer of 34. So this just gives you another option of how you can do these 3x3 determinants, probably a lot quicker, unless you're splitting it up between people doing it the other method. And like I said, you can look for videos, shortcut method for determinant of a 3x3 matrix. You can find videos on how that works.